Welcome everybody today. I very much appreciate the invitation to come and speak, the invitation from Deborah and the rest of the organizing committee. And the way since I am a scientist, I'll frame the talk around some science questions. That's usually how we start our research. We all know, I always pick on my undergraduates about the scientific method. So first off, and I think we probably know the answer, but I'll go a little bit deeper into this. What is causing the warming? Okay, what are the causes and impacts? Next, and what are some of the indicators of climate change? How do we know that climate change is happening today? Next, some predictions for the future. First, what we know for sure, and then moving on to some of what I call the worst case scenarios. Things that will most likely happen. The biggest question on the worst case scenarios is when they will happen. Are they going to happen next week, next year, next decade? We're confident these things are underway. It's just their feedbacks make it complicated in their difficult systems, complex systems, and it's difficult to get the timing right. Well, I doubt I have to go through this very much for this audience here today, but I do get the question, is global warming happening? Well, global warming means the globe is warming up. Now, I think we all know that climate change is much more complicated than just the average temperature of the Earth, which is shown on this graph. And you can see there's a big bar covering up part of that graph. Why have I done that? Well, this is, again, something when I'm teaching, I'll start with this graph and I'll block it off there because this was the temperature record I looked at back in about 1991 when I was an undergraduate. And there was some, at that point, I would call it legitimate scientific debate on if the Earth was abnormally warm. Jim Henson had just gone before Congress and said that global warming, using those words, was a big deal and something that we should be worried about. And he was saying that we had had just one of the warmest years on record previously and said this was caused by humans. So what has happened since then? Because that was a great example of a scientist making a prediction. Well, we've kind of gone off the charts. And now at this point, I don't think we can find anybody that would disagree that the Earth has gotten significantly warmer over this record stretching back now almost 130 years. There's been a clear warming trend. So let's dig into that a little bit. Well, again, in this audience, I think I understand most of you know this, but what's the primary culprit in this warming before I go on to some of the other cast of characters? Burning fossil fuels. And I like to emphasize that these are in the three phases of matter. We like to talk about solid, liquid, and gas. So there you have it. And why do we do this? There's a reason, of course. We do it to generate electricity, to provide transportation, and directly to generate heat. For example, I heat my home with natural gas. And I think we all know that the problem is that when you combust these fossil fuels, they're all carbon-based, you release carbon dioxide into the atmosphere. So what's the link? It's linking CO2 and this warming. Well, this is again incontrovertible that the amount of carbon dioxide in the atmosphere has steadily increased over the last, this is direct measurements over the last 50 years. We have what we like to call proxy records. For example, we can look at air trapped in an ice core to go back even farther than this, but this is 50 years of a measurement being conducted in Hawaii. You can both see the clear increase, and you can also still see the natural cycle, the natural rhythm of the Earth breathing in and out. This is the northern hemisphere, so you're seeing basically the biosphere breathe in and out CO2 each year. You can see that year to year that is a very important variation, but it's swamped over the course of the 50-year record. And along with that, again, we have increasing global temperatures. Two key things from the science point of view before we move on. And one is that we have a mechanism. It's not just that two things are happening at the same time. We understand that CO2, it traps heat, it traps infrared radiation, and that's the technical term. We call it a greenhouse gas. It amps up the greenhouse effect and causes global warming. Again, the other thing is something I mentioned a minute or two ago, is that this is a prediction. Once we started seeing CO2 go up, we predicted air temperatures would continue to increase, and that has indeed been the case. So some strong, this evidence now we're confident about. What are some other sources of warming, though? Since we know the basics, and since Rainforest Action Network is one of my sponsors, certainly let's mention the role of deforestation going on throughout the globe. Pretty simple. Plants and trees in particular are made of carbon. When you burn them or even just let them decompose on the ground, they release that carbon and return it into the atmosphere. I teach a class called Earth System Science, so that I'll talk about how this is a transfer of carbon from the biosphere to the atmosphere. And this is responsible for a decent amount of the, still fossil fuels dominate, but this is about 20% or so of the CO2 we put into the atmosphere. But it's also a double whammy. Why is that? Because two things happen. A, you have the direct emission of CO2 from deforestation. Also, forests can act as what we call a sink. They act as a sponge to suck up some of the excess CO2 that we put into the atmosphere. And by destroying these forests, we're removing that sink. So it's really a double whammy there. But let's move on from CO2. I won't talk extensively about this in the rest of the talk, but there's a lot of current focus in the climate change community. Not myself, I do a different type of research, but focus on soot, or we more technically call it black carbon. But this is a strong warming for a couple reasons. It absorbs solar radiation. In particular, one of the problems, ice is very, very reflective. So the reason ice sheets can persist and glaciers can persist is because they reflect a lot of the sunlight hitting them, and so they don't warm up. What happens if you cover the surface of ice with soot, you lose that reflection, and instead you get absorption of all that solar radiation that then causes a melt cycle, and it's a very bad feedback. And we're starting to recognize that soot is a very important player. This soot, we have done a decent job in the so-called developed countries, certainly in the United States. We've done a lot of work to reduce soot emissions, so that's great. Unfortunately, developing countries don't have the level of affluence we have, and many, or as you can see in this picture, are subsisting off of wood stoves. That's how they have to cook. That's the only option right now. Well, I shouldn't say that. My next point should be that we should provide them with other options. This is a great opportunity for technology transfer, and there are some really nice projects underway where they're trying to provide cleaner burning stoves, alternative cleaner fuel sources, so that we can cut down on these soot emissions. Obviously, these soot emissions also have really negative local air quality impacts. Moving on, there's a list of other gases. Adding up, they're still not as important as CO2, but each of them individually is a player. We have nitrous oxide. We have these dreaded chlorofluorocarbons. Not only do they cause global climate change and global warming, they're also responsible for the ozone hole. And we have been, again, that's a somewhat of a success story. We are reducing emissions of these. We have reduced emissions of these CFCs, but we still have work to do. Also like to point out another strong greenhouse gas is methane. And let me talk a little bit further about methane. Okay, again, strong greenhouse gas, much more effective at trapping heat than carbon dioxide. Just because of the bends, methane molecule has 5 atoms opposed to the 3 in CO2. If you count those up, that's 3 atoms. You can see 5 here. That gives it a lot more ways to capture heat, much more effective. The only good thing is luckily it doesn't stay in the atmosphere. There's a prominent scientist down at University of Chicago that calculates how long the CO2 we put into the atmosphere is going to reside in elevating the Earth's atmosphere, and he calculates thousands of years. It's a really long-term problem. Luckily, methane's not that long, but still causes a lot of warming. Many natural and human sources of methane, wetlands are a natural source, but we have a lot of anthropogenic sources, and that's why I had the cow there, remember. Ruminants are a large source of methane. So we have Right, so the next thing I want to get to is a little bit on fracking, because I know that's certainly a very current topic and one that a lot of people I know in this room are interested in. So let me just talk briefly and list some facts about fracking. I mean, obviously I think everybody has a point of view here, but just laying out some of this stuff. So first, fracking has increased dramatically in the last 5 years, about 500% at the data I looked at recently. It has probably been responsible for a reduction in coal use during that time, and I'll talk about that more. The reduction in coal is probably about equally due to increased electricity production from natural gas and also from renewable energy. So what is the good side there? Well, it turns out that it's much, much cleaner to burn natural gas than it is to burn coal. Okay, so don't get me wrong here. I'm not saying burning natural gas is good. I'm just saying it's only half as bad as burning coal. So that's the perspective I'm going to bring in there. Also, and I kind of being a little provocative with the flag here. I mean, I'm not talking about domestic energy policy so much here. I'm not talking about energy independence. But I sometimes look at this as a moral question. One benefit I see from fracking is that at least the impacts that we're causing from this fossil fuel extraction are being felt here in the United States. I think there is some benefit to that as opposed to being tied into the global petroleum network where extraction's occurring in really horrible conditions, for example, in Nigeria. So at least we've internalized some of the problem. Now, of course, there's much, we all know the bad. I think I don't need to go through it. I'll just kind of list some. Disposals of the fracking fluid, groundwater contamination, all the direct impacts from the heavy vehicle traffic on the roads, on air quality, and also some air quality from the fracking operation itself. So those are all obvious bads, which I think are rightly getting a lot of press. I do also want to talk about and return to climate in fracking, because this is something I'm very interested in, and if you read through, you'll find information about this, but I think it's a crucial piece, because remember, one of my big arguments for fracking is that we are emitting less CO2 into the atmosphere, and it's a cleaning, burning fuel. Well, that might not all be the whole story. What happens is that there's fugitive emissions. What that means is when you frack, you lose a lot of the methane out to the atmosphere. This is a big deal. Now, this is a place where scientists are just starting to gain some understanding. A couple of my colleagues, a friend from my postdoc and another friend from my graduate work have just recently published papers on this. The numbers are higher than we thought, certainly higher than industry was estimating. Why is this so important? Remember, methane is a large part of natural gas. It's escaping into the atmosphere, and any benefit that we may have been getting from turning to methane away from coal would be erased by these so-called fugitive emissions. So this is, there's a lot of science here. It's some subtle stuff, but it's extremely important to understand, and also extremely important to get some more quality scientific data on. So moving on, I think just summing up, or just going on to evidence for climate change, I think most of you know these, so I'll roll through these pretty quickly. So we have data for Illinois. We all live here. Well, I know we have speakers and probably some guests from out of state. But City of Chicago, 2012, warmest year ever. State of Illinois, we missed the record for the entire year by 1/10 of a degree Fahrenheit, but we had the warmest January through July, and it was the second warmest. Contiguous 48, warmest year ever. I think we probably all know that. Here, I just show you the temperature departures by month for 2012. The key there is just February was off the charts. We all remember that 80-degree weather we had. Incredible, incredible, unprecedented, and makes the other warm months not look that big of a deal, but you just have to understand how off the charts that was. Oh, sea level change. I mostly am showing this. I think most of us know about it. But if you want some really nice information, check out the US EPA's Climate Change Indicators Report. You can just Google it, or there's the link. I'd be happy to share these slides with anybody that would like them. Just shoot me an email. Great website that puts together all kinds of information. Being someone that works with plants a bit, I also like looking at the long-term average. The growing season has increased dramatically, almost 2 weeks over this time period, and recently almost a week. I mean, that's, again, it's hard to fathom that type of change in not just our lifetime, but a week within, quick. Arctic sea ice, again, I think this is one of my, I don't want to call it my favorite indicator, but I think it's one I've always kept track of for about the last 10 years, especially when it started to, when the floor dropped out of it about 2007, 5 or 6 years ago. The Arctic ice cap is melting. You can look at that pale red line as where the ice extent should be in the fall, and then you see where the ice actually was. That's almost about half. Almost about half. This sort of change is unprecedented. I'm sure that Karl, the next speaker, will talk about the impacts at these for Alaska, and this is obvious stuff here. So Northwest Passage may be open. Probably most of us in this room know the link to polar bears. Polar bears feed on the sea ice. So certainly, if you don't have sea ice, that puts you in a very, very precarious position. Just more data. I did attend a talk at a scientific conference a couple months ago in San Francisco. Heard a great presentation by James Bellog, the gentleman that does the chasing ice and does the pictures of glacial retreat. Phenomenal speaker, but he warned scientists to only use one or two figures with charts and numbers in a presentation. And sorry, James, I apologize. This, I've pretty much, I've talked about this, so I'll hit this quick. Just that, again, if you look at that blue line compared to the black dots, what you'll see is the global temperature has pretty much met expectations over the last couple of years. Okay, so we're seeing the warming we predicted. Just a strong confirmation of what's going on. So in the interest of time, let me just talk quickly about predicting the future. Okay, CO2 emissions. Just remember, when scientists are asked to predict the future, how warm is it going to get? Doesn't start with a science question. It starts with understanding CO2 emissions. So understand that policy aspect. So when you look at uncertainty in climate change predictions, remember that the biggest uncertainty is how much CO2 we're going to stuff into the atmosphere over the next 100 years. We have to figure that out before we can tell you, or scientists like myself can tell you, what the impact on global temperature is going to be. We certainly, I think I'm very worried about climate change and food security. Yes, the U.S. drought had a very big impact on our food production last year, but hey, we do have an agricultural surplus. That is not the case in many developing nations. I'll be giving a talk I think at the beginning of next month on that relates to food issues in Africa. Many nations don't have this surplus we have, and so any change to climate is a big deal. We all know about the drought that's is still underway. I just downloaded this version of the slide this morning. I usually keep this one pretty up to date. And realize that even without a big change in precipitation, there's a lot of subtle feedbacks. If you change from rain to snow, from snow to rain, that changes the abilities of mountains to be natural reservoirs. That's another big climate impact. So let me go through my worst case scenarios now, pretty briefly here. Sea level rise. With sea level rise, what we're seeing is that, yes, it's happening. I showed you that indicator. It is true, we're looking at some chances of dramatic sea level rise. Some of the time frames on that, like putting New York City underwater, those are 100-year time frames. I don't think that means we should discount that possibility just because something's in the relatively distant future. Certainly means it's still a big deal today. I go up, I didn't get a chance to tell Karl this, I do my research in Alaska. Why? Because those rapid changes are underway. This is with me and a student up there. There's some really nasty feedbacks that we're trying to track up in Alaska that again have to do with that other greenhouse gas, methane. As we get melting and the ice loss in the Arctic, we're releasing more and more methane. Now, this is, again, a longer term. Most scientists that are experts in the field would say this is a longer term impact, just because we have so many other methane releases right now. My last tipping point, I believe, is the Amazon, and that's a really nasty one. And again, go back to the Rainforest Action Network. So what we have there is a coupled natural system between the biosphere and the atmosphere. The rain that falls over the Amazon is recycled many, many times. This is why there's so much rain can fall there. It falls, gets evaporated by trees, and falls again. Well, if you start to break up this feedback with climate change, if you break that pattern, not only do you get a little bit less rain, but then you keep getting a little bit less rain, and the feedback escalates. And we've seen some record droughts in 2005 and 2010. So that's, I think I'll stop with that last worst case scenario, which again, since we've seen some record droughts, it's probably, pieces of it are already coming true. I appreciate your attention, and I think we'll switch over to the next speaker, and I think we're going to do questions at the end, right? So thank you.
Thank you, Dr. Potosnak. Thank you for your talk. So after hearing the science, the organizers wanted to invite somebody who could speak about the human impacts of climate change that we're already seeing in the US. So we invited Karl Wassily from Alaska to talk about basically ground zero for climate change and America's first refugees. It's an issue that I think we in the Midwest don't hear a lot about. Karl Wassily is a Yupik Alaskan. He's a community organizer and a musician with a BA in biology. He's been raising awareness on environmental issues since the catastrophic 1989 Exxon Valdez oil spill. Karl's co-founder and community organizer with Alaska's Big Village Network, and he's worked extensively on environmental sovereignty with tribal governments and communities in Alaska, including the Yukon River Intertribal Watershed Council and the Alaska Intertribal Council. So welcome, Karl.
So good morning. Thank you for inviting me to this conference. I'm not normally used to speaking and giving these types of presentations, so I appreciate the opportunity to share some of the knowledge. So my name is Karl Wassily, a Yupik person, Eskimo, and the Yupik are from the Bering Sea. I think I just wanted to just jump into this conversation, and I'd like to get to the questions. One of the things is Alaska is ground zero. Temperatures have increased significantly in the Arctic, more than over twice as much as the rest of the world. It's warmed twice the national average in the past 50 years. Global warming has caused significant decreases in extent and thickness of the sea ice. Wildfires are increasing the size and extent. Permafrost is thawing. And the thing I'm going to focus on is it really creates a humanitarian crisis for the people, the indigenous people that live in the Arctic. So to step back, I just kind of wanted to give an idea of the state of Alaska. Alaska has a massive landscape, especially when you start including the sea ice. But just to look at the land mass, it's 1/5 of the land mass of the United States. And it's a very small population comparatively to the rest of the United States. Less than 1 million people, about 710,000. And about 15% are Alaskan Native of that population. If you look at the Illinois, it can fit into Alaska 11 times. It's Alaska is bigger than Texas, Montana, California combined. And Alaska has about 111 times the amount of inland water as Illinois. And as you can see, Alaska is there's, right here is listed Chukchi Sea, the Arctic Ocean, and Pacific Ocean, and the Bering Sea in between. And the marine coastal area is about 50% more than the rest of the continental United States combined. So it's a very large coastal area too. There's 20 Alaskan Native languages that are spoken and a number of dialects, so it expands with the dialects. Just to give you an idea, there's about 213 very remote Alaskan Native villages that are only accessible by airplane and boat during the summer. So they're remotely isolated. The villages are about 60 to 90% dependent upon the resources from the land. In the villages, there are stores, some smaller stores. There's basic supplies are extremely expensive, and with the villages being at extreme poverty levels, both recognized federally and internationally, it's very important to access these traditional subsistence resources from both the land and the water. There's some blueberries, and you can see here there's salmon is for my people, the Yupik is one of the most important species. About 75 to 80% of our diet traditionally has been directly from salmon, but berries. There's some salmon berries in the lower right, which are used, collected and gathered and used throughout the winter. You can see the fish drying. Drying fish is also critical for the winter supplies. So the long summers allow for us to gather foods for survival. In the remote areas, otherwise we'll see migrations of people, which has already started to occur. Here, the significance of the sea ice. I wanted to emphasize the sea ice again, not only for the polar bears, but also for the walruses that haul out, as well as seals. And all these animals are the Inuit Yupik rely on for sustenance and sustaining our communities and traditional ways of life. It's beyond just access to food. It's a spiritual connection that we have as well. The cultural aspects of and traditional laws of sharing the resources with the various communities, including urban Alaskan Natives, is critical. As we can see from we've had the largest extent, or the smallest extent of sea ice, the largest extent of melting recorded in recorded history, at least from these satellites. So I wanted to also, the importance of permafrost is so critical, not only for Alaska, in which 80% of the landmass has permafrost beneath it. Permafrost is basically, there's different layers, and that permafrost is critical for multiple species bioproductivity, as well as the traditional foods that we access. Here we can see a chunk of permafrost going off, combined with the melting sea ice and the storms. It's actually falling off into the ocean. Here's a riverine. The permafrost melting is causing the whole ground to shift down, and it's actually taken out. So it's increased the erosion, melting glaciers, and it's causing devastation upon many villages. And the Government Accountability Office has a number of reports. The last one in 2009, in the 2004 report. There's of 213 villages, 86 were impacted by flooding and erosion, and these are 31 of the villages that are imminent threat to relocate. So we have a combination of lack of infrastructure, not only lack of access to stores that folks in the urban areas have, but challenges of third world diseases and poor sanitation with the increasing storms, contaminating water supplies of the villages. So there's been a lot of media in Alaska, at least, regarding some villages that are planning to relocate. Kivalina, Shishmarov, and Nutak are all in the Bering Straits and Bering Sea, the coastal communities. If you look on the red, those are all areas that are highly impacted by the decreased sea ice, which provides a barrier for the storms. So one of the problems that we're dealing with is that there's no legal or institutional framework by governments and institutions to address the relocation for identifying the communities at risk, as well as providing assistance, whether for relocation planning, as well as the physical relocation of villages. Here we can see this is the native village of Kivalina, lost 50% of its landmass over the last 2 decades. So you can see it's eroding here from the side. Here's if you look at the far, I guess it would be the bottom right corner. You can see they've been having struggling. Native village of Kivalina has been struggling to find a location. As I mentioned before, 80% of the landmass is on permafrost. So finding a location to relocate is extremely difficult. And so, and then there's these barriers are not enough to protect the village, as I mentioned. Half the landmass has disappeared. This is the native village of Nutak. You can see it's surrounded by the oceans in our forefront and the rivers in the background. It's impacted by both the eroding villages, or eroding river, and to give an idea of the cost, the barge costs are extremely high for barge materials for the relocation. So that native village of Nutak to move is about $2 million per household of a village of 340. So the estimate's around $100 million to relocate the village, and there's no access to emergency funds under the current policy and regulatory process in both the federal and state. You can see the erosion is significantly impacting multiple villages. I wanted to emphasize that there's an intense psychological ramification, not only of moving. So of the 31 villages, not all of them want to move. Some of them are concerned that they'll lose their traditional ways and the cultural vitality of moving, and some of them might be forced to relocate where they don't have access to traditional foods. So there's, under current state and federal policy, Alaska Natives are the most regulated people in the United States as far as ethnicity. So we're seeing it's very similar to what the Jews had to endure with the Nazi Germany. So there is a level of colonialization that's severely restricting the ability of people to access clean water, traditional hunting, fishing, gathering, and harvesting from the land. I wanted to show this slide because this is a unique event that occurred about a year and a half ago. If you can see, there's this orange substance that showed up one day in the Arctic. It was called the orange goo by Fox News and a number of other groups, but it was unknown. It took a year to figure out what it was, and finally, under electron microscope, this orange goo was basically a fungus, and it came probably. There's still no idea where that came from. So we have a number of factors that are unknown that are happening in a number of ways, including. What we're seeing is the loss of here we're having skin lesions on this bear, circled the skin lesions and hair loss. On a polar bear, this is just last 3 months ago. And here we have other skin lesions. These are ring seals. And ring seals you can see the hair loss and the actual bleeding from the skin lesion. And walrus here also, we're seeing skin lesions. And their behavior is about the same, but we're seeing physical changes with the animals. So I wanted to make sure that we also address some of with the receding ice and changing conditions in the Arctic, we're also seeing a massive rush by the United States and other Arctic nations to move into the Arctic with unsustainable resource development. Here's the Red Dog zinc mine, which is in the Arctic, and it's the largest polluter in the United States. According to the EPA toxic release inventory, it's 4 times over the last 5 years. So they've been leading the pollution in the United States toxic release inventory. We also have this is the Shell drilling rig Karl, and as you know, there's been a lot of media about the drilling in the Arctic. This is just they can't maintain these rigs up in the Arctic with the sea ice. So this was actually in the North Pacific, in which this Shell Karl ran aground. And so the fossil fuel expansion and the current policy is exacerbating not only the psychological impacts to our people, but it's also exacerbating the climate change with the unsustainable energy policies and unsustainable energy practices. So instead of addressing the root causes of climate change and protecting the human rights of the indigenous peoples, we're seeing a policy in the United States to move forward on the extractive industry and despite the energy security. Currently, Alaska is an oil state. About 90% of the budget's dependent on oil, but it really doesn't provide security, as about 80% of it is not even used in America. So it's a lot of even the current resources that are extracted are not used in the United States. They're exported overseas. So even if there is expansion of oil and gas, it's not going to provide for an energy security for the United States. So the combination of the lack of addressing climate change and the policy that have been put in place are really putting a burden on our indigenous peoples, and as the water resources are going to be one that's going to be continuously fought over, especially, and so that's kind of like something that we wanted to make sure that folks in the rest of the United States are aware of, because this is probably coming soon to a reality near you. And one of the questions I just wanted to put forth as a scientist also is how why should one way of life survive so another? Why should one way of life die so another could survive? And that's the question of climate change and the climate crisis from an indigenous perspective. Is the current process of extracting these fossil fuels and dirty energy and false solutions to climate change the correct way to go. And one more thing I just wanted to show is a quick visual of a storm event.
The tides is still coming up, and the surf is getting higher. Cocky they move or we're here, we're
than a week may force more people to abandon their homes in the village of Shishmaref. This is home video from a recent storm that washed away several boats and flooded part of the village. Tonight's storm is expected to cut further into the already eroded shoreline. Many who live on the barrier island just south of the Arctic Circle say this latest storm has more people talking of moving the village onto the mainland. Villagers hoped to move by 2009, but now say the village may not hold up that long.
But hope that gives folks an idea of what we're dealing with on the ground in Alaska in a short amount of time. I was able to share this information with you. So thank you very much.
So you can keep those questions coming up if you have them, but I'll start. Hopefully I'll be able to read everybody's handwriting. What is your perspective on climate tipping points? So this is for Dr. Potosnak.
Great, thanks. I think tipping points are, of course, very, very interesting. Are they defined precisely? Probably not. I would just say we usually think them about a nonlinear change, and that's why we look at the Arctic sea ice. There were aspects of the Arctic sea ice that progressed as we expected. But then it doesn't show up so well in the one plot I showed. But the change in 2007, it looked more like a step change. Instead of, let me get it right to your perspective. Instead of something like this, it was boom. Okay, and then it kind of plateaued for a couple years, and then in 2012 we had, again, as Karl pointed out, we had the worst sea ice. So that's one that's a tipping point we've seen already. Other tipping points, by their nature, are very difficult to predict because they're what we call nonlinear responses in complex systems, and by that, when you get a small steady change, it gets amplified, and the Earth system always does that. And it's just our best computer models. Some of them come up with tipping points. Others come up with different tipping points. Putting that aside, though, we have so much clear evidence for impacts that are going on today. That the steady rise of temperature over the last 130 years. I mean, yes, that wiggles around some. We know enough. We can almost put the tipping point issue aside. It's going to be very difficult for us to say we've crossed this line and this is going to happen. I think people do say that because they want the security of it, but overall, there could be tipping points out there tomorrow and next week. Some of them could be 10 to 50 years out there. And regardless of when they occur, it doesn't really change the sense of urgency with which we should act, in my opinion.
Okay. Next one's for Karl. Considering the nation states that inhabit the Arctic, are all feeling the effects of climate change equally? I.e., do Alaska's problems mirror Norway's? If so, are there any pan-Arctic peoples' alliances? So are all these villages, nation states?
Yeah, that's a good question. I actually have a little bit of experience. So there is the Arctic Council. So I guess I'll start with the last question. There is the Arctic Council, which has permanent members of indigenous peoples from the circumpolar Arctic, and some of those voices are being kind of muffled as the Russia and the United States aggressively move toward, and Canada move toward resource development. So the first, can we repeat the first question?
Are all the nation states feeling the effects of climate change equally?
So yeah, each region is different, and I think that's where we're going to come up with local solutions. The local solutions are going to be the most critical at providing the efforts of relocation. So this is it's at a tipping point. There is going to be relocation of villages. Climate migration is happening. Climate migration is a term that needs to be addressed in policy on multiple levels by local, federal, and Arctic nation states.
Thank you. Does the sun have any role? I'll try to go back and forth. Does the sun have any role in climate change? Is solar activity steady as she goes?
There have been small changes in solar activity. The key there is looking at the sun and comparing it to carbon dioxide and methane isn't so complicated. because all that occurs, we call those forcings, the inputs into the model. And so we can actually look at the contribution of the sun, compare it to the contribution from CO2, and we're doing an apples to apples comparison. And I just briefly, it was just sort of a just an illustration of all the different forcings when I talked about modeling. And the sun's something, the change in the sun, it's gotten a little, the output's gone up a teeny bit, and it accounts, maybe for about 10% of what, of the forcing from CO2. And again, we can be much more confident about that because that's just at the beginning of the process of that these global climate models have to deal with. All the complexities, those tipping points, there's somewhat more uncertainty there. Since the sun and CO2 are inputs, we can compare them pretty directly. And yes, the sun warms us up, there's no doubt, but has the sun caused the Earth to warm up over the last 140 years? 97% of scientists would say no, the sun's not the only explanation. Climate scientists, not. Great.
Okay, Karl, there's been a lot of radiation released into the ocean from Fukushima coming on Kuroshio, currently and in air transport, according to recent research. What is the impact of radiation on sea life in Alaska?
That's a good question. I know that I showed a couple pictures that actually look like they could be radiated animals. I think there's a couple different factors. One is the Cold War brought a lot of dumping directly into the Arctic Ocean. There's also the ideology of progress and development meant that this ice is going to be here forever. So there's a lot of nuclear waste that's supposed to have been classified, unclassified, buried in the permafrost, which is melting. And so these are starting to get into the water systems and draining into the Arctic in both Russia and Alaska. So radiation is, and then atmospheric testing, the 10,000 bombs that have been tested, the radiation does drop out into the Arctic significantly. So radiation could be a factor. The studies that they did from Fukushima to look at cesium-137 in these animals was not significant, according to the researchers, but they didn't look at things like the plutonium and other long-lived toxic radionucleotides that are actually in the Arctic Ocean. So that's an excellent question.
Thank you. Okay, for Dr. Potosnak, I'm going to collapse a few of these questions together. They all involved what can we do and what's really happening. So let me read a couple questions at once. Can our own personal carbon footprint really make a difference to diminish global warming? What is the most impactful thing an individual can do to combat climate change? Does recycling have an impact? What's the hope that geoengineering will save us? What's the progress being made on investigating, researching geoengineering possibilities? What's the climate warming skeptic's best argument, and how would you counter that argument?
I think it's worth, there's great information online. I love the Energy Information Agency. It's a government website, but real boring stuff, a lot of Excel files. They do some of it in graph form for you, but you can see where the CO2 is coming from. You can see where energy is coming from. What is the share of renewables? And if you start poking around, transportation's big. It's not all of our personal transportation, but if you think about the transportation that's moving goods around the country, that's very, very significant. And add that in with our personal transportation. So I would think consumption patterns, what we consume is very, very important, from the food we eat to the products we buy, particularly if those products are coming from China. There's a whole, if you want to do what we call life cycle analysis of those products, we find that the CO2 emissions are considerable. So obviously, public transportation, that's key. We're relatively fortunate here in Chicago. I mean, we have a robust public transportation system. It's far from perfect, but it's pretty nice, especially, this morning, like coordinating a bus and a train. Usually I'd be really nervous, but I could get on my cell phone, make sure, the bus is really on time, it's going to meet the train, it's all good. We're fortunate. There's a lot of other places in the United States, particularly out west, where public transportation is not so good. So I think that those are big ones. But just, I think the things you can think about are reducing consumption. I mean, that's the biggest. I usually, I give another talk, and there's a famous question of paper versus plastic. Which bag is better for the environment? It doesn't matter. It's what you put in the bag. Forget about the plastic or paper. It's all the stuff inside that bag. That's the damage to the environment. So it's really our consumption patterns, and then it gets to a really a social justice type of issue. I don't know. Do you want me to tackle one more, or should I?
I think geoengineering. Okay.
Yeah, geoengineering. Hey, I'm a scientist. I'll admit I'm a little bit of a technologist, but I haven't seen any convincing geoengineering scheme. Now, there's some simple things that we throw into geoengineering. For example, white roofs in Chicago. We have a white roof ordinance. This is very simple. If you use tar on a roof, which had been historically done just because it was cheap and available, it's a black roof, it gets really, really hot. So if you use a white paint and you do that in urban areas, you can reduce the amount of heating, especially locally in the city. Great, effective, cost-effective, works. No problem. So if you call that geoengineering, great. Mirrors and space, stuff like that. Hey, I'm a scientist. If someone has, an idea and they want to study it, great. But I wouldn't put any of our hopes. I haven't seen anything since we've been talking about this 10 years. Nothing seemed very viable along those lines. So I wouldn't dismiss them completely, but I don't think we should plan on any big breakthroughs.
Thank you.
I would just like to address that from a holistic perspective. The mythology of progress and development is one that intellectually must be challenged. I think there's going to be some discussion on that later, but this mythology of progress and development has to be directly challenged because of the third world countries and other developing nations are going to look at this progress and development. They want the TVs, the coal, things like that for electricity. So in order for the United States to lead the way, there has to be a just transition to renewable energy policy and the actual shift in the way that people, not only in their daily but as a society, operate. And just to give a quick example, traditional knowledge of the Yupik people have been sustainable for tens of thousands of years in the Arctic. Our creation stories actually can address some of these challenges that we're dealing with, and not only within our own communities, but on a societal level. So that knowledge and wisdom is so critical at this point in time to understand the holistic to be able to look at a holistic picture moving forward to a sustainable way of thinking, ideology, and society that respects Mother Earth and the water and food and other sources that we impact not only individually but as society.
Thank you so much to both of our speakers.